Okay. So functions, the most important part of functions, the starting point of it, is knowing its definition. So when you hear functions, what do they mean? What is a function? It's mentioned everywhere, almost in the whole past paper. You see in the whole exam paper, you see function, 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 sketch function, everything functions. What is it? That's the first question. Okay. But if you want to understand functions, then your first question should be, what is a relation? So it starts from the relationship of numbers. How do this number relate to another number? How do you move to this number to the other number? Those are relationships now of numbers. Now we are saying in mathematics, we have 4 relations. So we have 4 relations, of which one is a one-to-one relation. A one-to-one relation. What we mean by relation is, we need some numbers here. So give me a set A, ask me to B, I think some F. I'll move 1 maybe to 4. I'll move 2 maybe to 7. I'll move 3 to 10. Some number there, this number here, this number here. If whenever I do whatever I'm doing with F to 1, it goes to 4. Okay, so if whenever I do one element of A, I get one element of B, a unique element of B. For each element of A, then that is the relation. This relation, when it's 1, 2, 3, this side maybe only 4 and 7. It so happens that 1 goes to 4, 2 goes to 4, and 3 goes to 7. Still a relation, but now because I've got 2 numbers on the left going to 1 on the right, then it's not 1, but a mean to 1. Still a relation. 1 relation. Because I've got 2 going to 1. I have the numbers 1, 2, 3. I have my numbers 4, 7, 10. But this time around, 1 goes to 4, 2 goes to 4. It so happens that 2 still goes to 7, goes to 10. What do we have? Numbers on the left, 1 and 2 are going to 4. We also have being shared. 2 is going to 4, so it's going to 7. That means that on the right also, we have 2 numbers on the left, 2 numbers, and 1 on the right. Meaning, we have men to men. So keep that. Another one, another possible relation is where we have 1, 2, 3, 4, 5. And then this one goes to 3. This one goes to 4. And this 2 goes to 5. So we have 2 elements on the right going to 1. Meaning 1 many relation. This is the 4th relationship. Now, these relationships in mathematics, they help us remember what we would define as a function. We are doing this because we want to get a way of extracting the function and how we'll be remembering. When we hear that, present this. By the way, we call these arrow diagrams. These diagrams here, they're called arrow diagrams. So present the information in an arrow diagram. This is what you'll be doing. So now we have examples of where we are presenting from ordered pair to from arrow to ordered pair. So now, out of all these 4 relations, by definition, a function is a rule that maps each element of the domain to a unique element of the range or the image. A function is a rule that maps each element of the to a unique element, range, or image. Unique. Let's go to 1. We have elements of A uniquely related to elements of B. Each element of A, for example, 1 goes to 4 only. 2 goes to only one number. 3 goes to only one number. So this is a function. Let's go to main to 1. Main to 1, 1 goes to 4 only. 2 goes to 4 only. 3 goes to 7. So 1 and 2 are sharing 4, but by the definition of each element of the domain to a unique element of the range, it satisfies also here, because 1 as an element of the domain has only one image. 2 as the element of the domain has only one image. So this 2 is a function. If you go to 3, main to main, 1 goes to 4. That is okay. 2 goes to 4. That is okay. But now the challenge is the same 2 goes to 7, meaning each part we have 2 as an element of the domain, 2 not unique. Unique means it must only go to 1. But what we're having here is 2 going to 2 elements. So not a function. 4. Once you see 2, how do I tell that this is not a function? If I see 2 arrows coming from one of the left, arrows from one number, I know it's not a function. Which number? The number on the left. So this 2 is not a function. Not a function. Meaning that out of all the 4 relations, we're only interested in 2. 1 to 1 and main to 1. These are the ones that you hear now in polynomials functions, calculus functions. They mean between 1 and main to 1. So, unless we have questions on this page, I want to bring up another concept. So do I get questions from this page? Okay, so we're still okay. Okay. Next, if I'm given ordered pairs, what do I call the domain and range? These are the most important parts that makes the function. So I will bring it in form of examples now. Given f from 1 to 2, from 3, from 5 to -3, and 10 to 20. A represent f on an arrow diagram. B, state whether f is a function or not. State the nature of f. C, find the domain and range of f. Then give statement out the ratio of the domain and range of f and f inverse. So I put a full detailed question here about the properties of ordered pair functions. So here, this question is saying between f and another. So from there, solution A. So put diagram here 1, and always be 2. Then we'll pick the element of f. So I want to take the left and first element of f is, so we have 1, 3, 5, 10. On the right, we have 2, 7, 20. 1,2 means when you use 1, you must get 2. 7, when you use 3, you must get 7. 5 must get -3. 10 must get 20. So this is f. represent the other. That's all. The idea is, for example, there always be questions and hard questions. Don't say it's simple, this is correct. No, you can answer the question. Then put it on another diagram. So this is what you do. B, say whether f is a function or not. Instead the nature of f. Now is f a function or not? Go back to the equal functions. 1 and 1. Okay. Where does this fall? 1. So I can start by saying the nature. I mean I can start by saying whether or not it's a function. Okay. Is it a function? Yes. And it's got 1. Function. That's the nature. Done. Find the domain and range. Okay, see domain. Now you honor the domain of x. And if I want to put that it's always y. So the x domain. So x means all the m's in here. So 1, 3, 10. Range so 2, 7, 33, 20. But that does not matter in sets. So the inverse of f. So I'll put it on this same page. I'll put it here. D. The inverse of f. For all pairs, the inverse of f, you go to the same pairs and you switch. Instead of saying x, y, you say y, x. Instead of saying 1, 2, we'll say 2, 1. Instead of saying 3, 7, we'll say 7, 3. Instead of saying 5, 5. And 20, 10. This the inverse is that. Creating now with the y's and see what they give you of x. That is inverse. So that's how we use this in other types of functions. And state domain and range. Okay. What's the domain of this? Let's see. What's the domain of the inverse? The first numbers forms the domain. So 2, 7, -3, 20. What's the range? Just the entries both from the range. So 1, 3, 5, 10. These numbers. Then E, the derivative now is asking us to make a statement. Here a statement of the range of domain and the range of f and its inverse. I want you to observe that what we call the domain for f and called range for f inverse. The same 1, 3, 5, 10 is the range of f inverse 1, 3, 5, 10. The range of f has been called the domain of f inverse. And you guys, the reason why when we have function f of x is equal to 1 over x plus 1, they ask us to find the range of the domain. What is it of f inverse? Is the range of this was 1, 2. The f inverse of x is the range of f of x. This is very, very important. So let me quickly introduce the composite functions. Composite ordered functions. So if you're given f 1 to 2, g 2 to 5, 4 to 8, and 7 to 11. Then they ask to find the domain, range, and represent it on an arrow diagram. Let's see. So g of f of x is always g of f. Meaning, if we have a normal function, you would get x, take it in f first. Evaluate f, what you get, you take in g. Or you go in g, where there is x, you take the whole f. These are ordered. The secret is, whenever they ask me to find the composite ordered, I got the inner function, the one inside the f, and list the first entries of f as my domain. So my domain here will be 1, we'll close, go to the next, 3, we'll close, go to the next, it will be 5, we'll close. Then this will be there. The domain will be strictly for the inner function. Now let's see the corresponding ones. So you follow now f, because we must vote in f first. So where does f take 1? F comes to 2. Do we say 2 in the composite? No. We go to G now without, because we have function of x, f of 1 is 2. We're putting it inside G. So we take 2 to G. So what is G of 2? G of 2 is 5, meaning here 5 will respond to 1. 3 to 4. 3 to 4. When you go down, where does 4 go? In G, it goes to 8. So 4 to 8. So meaning 3 will go to 8 in the whole composite. 3 to 7, 7 to 11. Like that. So this is our composite. Now this is telling us that if for any reason we go to F, get 1, it goes, maybe let's say it goes to 20. We go to G, there is no 20. Because there's no 20 in G, it means that the composite is not defined. It won't be there. So take note of that. Then, what will be the, state the domain. What will be the domain of this guy? It's 1, 3, 5. What will be the range? The range will be 5, 8, 11. An arrow diagram, 1, 3, 5. 5, 8, 11. How do we move? 1 to 5. 3 to 8. 5 to 11. This is G of F. Now take note, in a circle of these arrow diagrams, we do not repeat a number. What I'm saying is that in sets, you only list a number once, so that we're able to tell whether it is a one-to-one or man-to-one or man-to-many. Because if you list it so many times, it will confuse you. You want to know whether it's one-to-one, man-to-one. In fact, what you'll be seeing will always be one-to-ones. That's why we do not repeat a number there. So do you have questions? We have 2 minutes before the 40 cuts. So what we'll do is when it cuts, we quickly join back. So please ask. Okay, no questions. That's good. So I assume that we are together this far. Because at the end of this, after the examples, then I'll give you a task and I'll follow you up that you submit the task. Here you must be submitting tasks. Okay, so we can okay, so I think we can now log out and log back so that we look at some more examples.